You've probably been on a website, seen some cool dashboard, and maybe you've played with a slider and watched a graph change in real time. And you've probably thought, wow, how on earth did they build that? It looks like it must be super complex web development, right? Well, today we're going to pull back the curtain on a really powerful tool that lets data folks build these incredible apps, all without having to be a professional web developer. Let's dive into how it's done. So that's really the big question, isn't it? How do you go from a static spreadsheet, just a boring old data file, to a living, breathing web tool that people can actually use and interact with? In this explainer, we're going to walk through the one core concept that makes all of this possible. And here's the first thing to know, and it's kind of a relief. You don't need to be a full-stack web developer who knows 10 different programming languages. The secret is actually way more elegant, and it's focused specifically on working with data. And that secret, that magic word, is reactivity. This is the engine that drives these interactive applications. Seriously, once you grasp this one idea, everything else just clicks into place. It's the invisible link between what a user does and what they instantly see on the screen. Okay, so first things first. Let's unlock the why. Why do we even need to make our data interactive in the first place? What's the point? This quote from our source material really gets right to the heart of it. A tool like R-Shiny is all about creating a what-if machine. It lets anyone, not just a data scientist, play with the inputs, change a date range or pick a different category, and immediately see the results of that change. So how does it all work under the hood? Well, it turns out any of these interactive apps can be broken down into just two super simple parts. And here's that core structure. It's really this simple. On one side, you've got the user inputs. These are the controls, the drop-downs, the sliders, all the things you can click and change. And on the other side, you've got the reactive outputs. These are the results, like plots and tables that automatically update. That's it, controls and results. So what connects those two sides? That's reactivity. Think of it like an invisible engine that's always waiting. The moment you move a slider, that reactive engine detects the change, it instantly reruns whatever calculations are needed, and then it pushes the new results to the output. It's the automatic link between cause and effect. Now, this might look a little technical, but hang with me because the idea is actually really simple. In the code, you use these basic commands like file input or select input. And what Shiny does is it takes those simple commands and just translates them directly into the controls a user sees on the screen. Like a browse button for a file or a nice drop-down menu. It's a direct one-to-one map from simple code to a working interface. Okay, now that we've got the basics down, let's look at a really important distinction. See, not all of those input controls are created equal. They can be either static or dynamic. A static control is pretty much what it sounds like. Its options are fixed. They're set in stone by the developer. A perfect example from the source material is a drop-down menu to choose a color for your graph. The choice is blue, red, green. They're always going to be the same, no matter what data you're looking at. But this is where things get really, really cool. Dynamic controls. These don't have predefined options. Instead, their options are generated on the fly from the data that the user themselves uploads. And this is a total game changer because it makes the app feel incredibly smart and tailored to exactly what the user is trying to do. And this slide just shows it perfectly. Look at step 1. Before you upload a file, that drop-down menu for selecting a variable is just empty. It's waiting. But then look at step 2. The moment you upload your dataset, Shiny peeks inside your file, finds all the column names, and instantly populates that drop-down with them. The control literally adapted to your data. All right, so let's put all these pieces together now. We're going to walk through the exact user journey of a simple but powerful histogram app, just like the one that was built in the source material, to see how all these concepts come together in the real world. So here's the flow. First, the user clicks a button to upload their own data file. Second, a dynamic drop-down menu appears, now filled with the variables from that specific file, and they select one. Third, they use a simple static drop-down to pick a color for their chart, let's say blue. And finally, that reactive engine kicks in and bam, the histogram instantly appears, plotted with their data, their chosen variable, and their chosen color. Now let's connect those actions back to the concepts we've learned. Uploading the file, that uses a file input control. Selecting a variable from that file, that's our dynamic UI, where the interface is literally built on the fly based on the user's data. Choosing a color is a simple static control. And seeing the plot update, that's a render plot function, which is just a reactive instruction that says, hey, redraw this plot whenever any of the inputs change. Each step has a clear concept behind it. Of course, building the app is just the first step. The real goal is to get it into the hands of other people, your colleagues, your clients, maybe even the public. And Shiny gives you a few clear ways to share or deploy your work. The source material lays out three main options. The easiest is using a cloud service like shinyapps.io, where you can publish your app to the web with just a few clicks. For more security and control, a company can host it on their own private server. Or, for collaborating with other data folks, you can just share the code file itself and they can run it directly. And this is really the big takeaway, the so what of all this. This whole approach democratizes data science. It lets a data analyst, the person who knows the data inside and out, build and share a custom tool without needing a whole separate team of web developers. They can put their analysis directly into the hands of a decision maker, right in their web browser. So, it all comes back to this. By understanding that core idea of reactivity, the difference between static and dynamic controls, and the basic anatomy of an app, you can turn pretty much any data set into an interactive experience. And it really makes you wonder, what data do you have? And what story could you empower other people to explore with it?